Jump.
Jump.
Jump!
Often when we program, we use if or while statements. These require us to sometimes jump back up or skip lines of code. .s doesn't want to miss out on the fun, so she has many commands that do just that. These are the condition flags. They each contain one byte, where a 1 is up and a 0 is down. When we run a test or compare, which happens in things like if statements, flags will go up or down according to the conditions. They can also be set when you run instructions like add or sal.
If you were to say test %RAX, %RAX, this will ask if %RAX equals 0. If it does, the ZF flag will go up. Then, if I were to call JE, we would follow through on the jump. The sign flag goes up or down depending on the first bit of a 2's complement integer. The carry flag goes up when there is a carry in the most recent operation. This is often used to detect overflows. The overflow flag is true if you have two 2's, complement numbers where the signed bit is the same, but the result has a different sign. The logical instructions initialize the CF and OF flags to be down. For the shift operations, the OF flag is down and the CF flag is set to the last bit to be shifted out. So if a 1 is the last bit shifted out, CF will be true. And if a 0 is shifted out, CF will be false. When we ask if the SF flag is up, like with JS, the states of the other flags are irrelevant. We can see on the right where those jumps are commonly used. However, the jump line itself doesn't check the variables, it checks the flags. After the command is the line we want it to jump to, such as JLE.L6. This is another way of showing the same data. It's really about what speaks to you and how you want to visualize it. However, if you're talking to me, you must of course say things exactly the right way or I will throw a fit or do something stupid.